Good morning, everybody. I'm going to let this settle for a bit and do a mic check. So I have a slightly different setup. Hopefully, hi, Captain Price. Hopefully, audio is okay. Okay, so I had to ditch my. Okay, that's good news. Good morning, Glazer. Good morning, Tyler. Good morning, Captain Price. Good morning. Who else is here? Killer Pear. So, yeah, so I've got a new. I had to give up my elbow camera, but I have a new one on order. So my old laptop, my Linux laptop that I like a lot, is just getting the sound is getting too crackly in those videos. So hopefully this is an improvement. Um, I'm probably not going to spend $300 on a Blue Yeti mic setup or anything. So I hope that this is good enough that everyone can hear the words clearly. The one thing that I think probably you'll hear more of is my mechanical keyboard under here, so apologies for that, but I'll try not to talk too much at the same time that I'm typing. Okay, so I'm glad that some of you are here. Probably some of you had a crazy week behind you. If you did, I'm glad that you're here, and hopefully that means that things are settled. If you did not have a crazy week, then I'm thankful for that as well. So um, if you're sitting in someplace funny to consume the video, like a parking lot and looking on your phone or something, then good on you for doing that. And it's not easy times there in Northern California. Okay, so I think I finished sort of most of the major course updates. I have not posted all the content, but I want to show you before we get talking about content this morning. Oh wait, I'm doing the wrong class. This is Monday. I'm doing the completely wrong class. Let me switch. All that counts that I said, but I was all geared up to do a different class because for some reason it's just not sticking. Okay, we are the assembly class. Which that should say 10 on it. Okay, we're back. So I think for your class, I actually haven't done anything major. I have done one thing that hopefully you like, so I will try to never make a change to the way the course is set up that I think would make your life harder. If I make a change at this point in the semester, I'll try to make a change that makes your life easier. So let me just show you what that is. In terms of content, by the way, I have loaded up through week 15 now and both individual projects. So I just started this morning working on week 16's content, and I should have that up. So by tomorrow, your whole semester's content will be posted and available to you. Okay, this is, yeah, assembly. So let me just show you the thing that affected the syllabus. So if you go look at this review week, November 23rd, and I hope that you're going to like this change. This is actually how I always run this course. We need a moment of breath at that point in the semester because we are doing lots of difficult things. So if you go look at the week 14 module right now, what you're going to find is there is not the usual content. So there's no goals for the week, there's no reading and lecture, there's no homework, lab assignment, piazza discussion, or reminders. So week 14 is kind of a one-off. I will be doing a lecture that week, so if you click on review, you'll see that I am going to do lecture, and the focus of the lecture is going to be in part just to do a review of the things that are most important for you to complete the second project. So we'll talk about the concepts that are going to be involved in the second project, but the other thing that we're going to do is I'm going to open up the second project. Now this is a long time in the future. I realize that. This is week 14. But just so you know, that review week, I am going to do a lecture that week. We're going to talk about the second project, and I'm going to try to give you some tips to help you be successful on that project. So that's a fairly important change to the course, that week 14 doesn't have the usual routine in it. And I want to show you on the syllabus what that affected. So that means I had to remove an assignment, a homework, a lab, and a discussion. I had to remove all three of those types of assignments from week 14. So on the syllabus, what that means is we're now only counting 14 homeworks, 14 labs, and 14 discussions. So I will still drop the 2 lowest scores on all 3 of those types of assignments. But now, since week 14 doesn't have those assignments, that means the total number of them is 16. So if I drop your 2 lowest, that brings us down to 14. So that's a change that you'll see reflected in the syllabus. And if you go to the home page for the course, you'll see an announcement about it at the top. So week 14 update, that's what I'm talking about here. So it will change your work routine, your workflow for this class during the week of Thanksgiving, but it's the way I like to run this class. So hopefully that doesn't mess anybody up too much. But I think you would rather open up week 14 and be pleasantly surprised that there isn't something than that there's something that you didn't expect that's new and additional work. So Atsy is here. Good morning. Gersovac, good morning. Hello, everybody. If you didn't hear me say it at first, I've got a new setup. This is usually I use this for when I do drawings on my pad, but it does have a microphone, and I believe I'm now sitting at a Windows computer, so I'm very unhappy about that, since I'm not a fan of using Windows, but I'm able to clean up the audio a little bit. And actually the streaming software is fancier, and Windows those things tend to be. Thank you. Good morning. Okay, so that's that stuff. So let's go into the week. I'll do it through the schedule this time. So we are starting up week 4. And well, let's just go through, and then we'll see what we encounter as we do that. So this week is really just about getting more comfortable with the HLA language itself. I've probably said this, but if I haven't said it, why I like HLA as a language for this class is because it lets us program in high-level style. So we can use variables, and we can write if statements and loops. We can create functions, pardon me, which in HLA are called procedures. So when you see procedures, it's a function. Or if you've used a language that calls them methods. HLA calls them procedures. So HLA offers us all of the high-level language programming structures. But what it allows us to do over the course of the semester is we can start to remove the high-level programming structures, and we can replace them with assembly style programming. So for me, I think it's a lot more satisfying to write programs that actually do something interesting, having a mix of high-level and low-level techniques involved, as opposed to writing pure assembly where the programs you would write would be quite small and wouldn't really do anything that's all that interesting. So we're going to look at how do you implement a procedure in the HLA language, and then how do you call or invoke a procedure in the HLA language. It is HLA, so there's some things to get used to, but for the most part, because you've had a programming class, you should recognize the basic setup. Okay, that's the goals for the week. So the readings, we are going to be using random numbers, so hopefully this one works. Let's see if it works. It does. So no one brought this up until way late in the week, but apparently my link last week to the standard input handling wasn't working. So this one is working. Anyway, we are going to be using random numbers in HLA. One of its high-level features is that it has libraries, and those libraries include random number generators. That's just so we can make a more fun program. And then we're still kind of spending time using the introductory content about the HLA language itself, and then we're adding procedures to the mix this week. Okay, I never do the I never look at the homework questions, but as is true every week, as I'm doing the readings that I've assigned to you each week, well, this time at this point I'm ahead several weeks, but as I'm doing the reading I've assigned to you for that week, I am writing questions out of the reading. So if you have the readings, I recommend you read them first, but that's up to you. As long if you have them there as a reference, then hopefully it's working for you, that you're getting through the homework questions. Okay, I'm going to come back to the lab assignment. That's where we'll spend most of our time this morning. Yeah, we're doing good on time. So I'll come back to the programming assignment, and I will sort of build up to the skills that you will need to solve it. After that's the Piazza discussion. So one of the things that I'm doing with your class in terms of the Piazza discussions is I'm sort of adding in the sort of bonus content for the class through those discussions. So my hope is that if each of us goes and we look up some small part of the larger question, then collectively we have gathered together a nice substantial answer. So the question this week that we're going to look to answer is x86 the only processor architecture? Now, sometimes that means that you have to go look up the term to understand the question. So we may need to look up what is a processor architecture. I'll give you the short answer. It sounds like more than it is. A processor architecture is basically what instructions does a processor execute. And I guess processor architecture sounds cooler than that. But when you hear someone say processor architecture, they're talking about a specific processor and the instructions that it was built to execute. So it turns out that different processors are designed in different ways, and sometimes they're actually designed to execute a different set of instructions. There's usually common instructions like add and subtract are very common. Ways of moving or copying data are very common. But you do have specialty processors or specialty architectures that are designed for particular kinds of problems like graphics processing. So anyway, the point there is that if you sort of have to take a quick side trip and get a definition for processor architecture, that's a good thing. And if you do that, then you might share it in the discussion. This is kind of bonus content, though, because we have plenty of other things to cover. That sometimes we need to pick up this bonus content in the form of discussion. All right, so that's the discussion, and what's the last thing here? Just reminders about what we do each week, and then that the individual project has been posted. I think I may have mentioned that I might do a quick start us on a setup for that. So if we have time, we'll do that. Okay, let me launch my virtual machine and get ready for this lab. Okay, so I'm hiding my browser just because I want you to see my programming environment, but I still do have the lab assignment open. Probably many of you do as well, so that I can read off of it as we go. But before I do that, I just want to talk a little bit about HLA procedures. Some of you may have this lag, by the way. That's normal. Do you see my my Ubuntu is saying failed to send host log message? It's fine. It will start up at some point. Okay, here we go. my virtual machine is probably going to run much better on my Windows computer that has more memory than my old Linux computer that's becoming not usable. It's losing keys and the audio connector's got a crackle in it. Okay, so everyone's seen this before. I'm actually going to start up a sample program first. So same thing that I always do. I open the CSCI 10 assembly folder, and then I use the tool to open a terminal here. Oh, this is going to be a much better experience for me. And then I'm going to open the editor. And I'm going to stretch it out a little bit just so you can see more of the code as I work on it. Okay, so that's my mechanical keyboard if you can hear it. I have the camera mounted kind of high, but anyway, if you hear the clickety-clack, apologies for that. And then I'm going to save that. And remember, I'll keep saying this for a while. Just take time when you're saving these files to make sure they go to the right place and then they get a good name on them. So I need to make sure that I'm on my desktop in the assembly folder, or my life will be slightly more difficult. It's not that big a deal, but way easier if I just do it this way. And then I'm going to say this is nope. lab4.hla. Again, with the .hla extension for HLA code, and then lab4 with no spaces. So don't put spaces in names of stuff. Generally in programming, it's not the best idea, but HLA sometimes doesn't like it. So just pay attention for that kind of stuff. Make sure it goes in the right place. Make sure it gets a good name before you click save. And then do I have to click this save to get it to see HLA? I forget, there's something funny about this. If it does not change colors, by the way, if you go to the bottom of the editor where it says plain text, there's a drop down there and you can switch it manually to be HLA. Okay, and I double clicked it. You could click it once and press enter. Just to get the syntax highlighting on. If it's not syntax highlighting, it doesn't mean anything's wrong. It just looks nicer this way. But I want to talk about procedures. And you should have had some exposure to methods or functions or routines or subroutines or procedures, depending on the language that you have used up to this point in your career. One of those words describing a functional unit. In HLA, they're called procedures, and we use them in the same way that we do all other programming languages. We tend to take portions of our program and we create procedures to make those portions of our program be more flexible and reusable. So in HLA, it looks like this. I'm going to make a greet procedure. So there's the whole procedure block. Procedure greet, begin greet, end greet. And you'll notice here, there's no parentheses. So this is going to take some getting used to, but if there are no parameters in HLA, then there's no parentheses. And if you don't remember parameters, I'm going to do one with a parameter here in a second. So it looks like a miniature program because effectively that's what functions or procedures are, is little miniature program units that execute in their own space in a way. But what I'm going to do is I'm going to move my output statement into that procedure. Now I happen to like these blank lines to make things a little more readable, but they're not required. So you could do that, but I think for teaching purposes especially, you can probably see it better if I put spaces. Blank lines. Okay, so there's a procedure. It's the name of the procedure is greet. Technically, in HLA, there is no true concept of return values. So that's nice. Now there is sort of a weird thing that if you see it, it looks like returns, but technically there's no true return values in HLA. That's not a thing to worry about yet, but this is a pretty standard setup for a procedure. The thing to remember right now is the way the setup looks. Procedure, the name of it, begin the block, the name of it, end the block, the name of it. That should look like the program that wraps around it because it's a very similar setup except for the program is replaced by procedure. The other thing to note is that procedures are created inside the program and before the program begins. So in this space, right between the include and the begin of the whole program is where we will put procedures. Now you're going to see the book tell you that you can actually use the keyword call to fire off a function, but I don't recommend that because you're going to get confused later when you have to use parentheses. So we're going to get in the habit of invoking procedures in the standard high-level language way, which is the name of it followed by parentheses with whatever parameters are involved. Now the greet procedure takes no parameters, so invoking or calling it just means empty parentheses. That no parentheses, when you define the procedure, that takes getting used to. Okay, so now I'm going to switch over here and I'm going to compile it. So HLA lab4.HLA / lab4, and it's just going to print the greeting, right? So that's the greeting. Now this is going to get a little bit hard to read, but so I'll try to keep it short in terms of examples. So I'm going to do one with a parameter now. So I'm going to say greet by name. Now if you do have parameters, then you do have parentheses and you put them in there, and I'm going to put the name in there, and that's going to be a string. So you can pass data to procedures in HLA, and it will work in most cases just like you think it should work. So I'm setting up to create a new procedure called greet by name that takes a name. And we'll begin greet by name. I always, by the way, do the begin and end all at once just to make sure I've gotten both parts. And then you can just use this parameter just like you would any variable inside the procedure. So I will say standard out.put hello by name. I'll put an exclamation point at the end. So this greet by name procedure, which I'm going to highlight to show you that you have to be careful about not crossing them over each other. If you supply it with a name, it will print out that name, hello, with an exclamation point on it. So let's just look at what we have. We've got the whole program, right? And here's where the program, the main block of the program begins and ends, and then above that are the two procedures. And just take note that they are separate from each other. So here's the greet procedure, complete, and then here's the greet by name procedure, also complete, separate. So be careful about crossing those over. This is challenging because this little program is already a mess. Every time you learn a more modern language like C++, or then on top of that Go or Python, you start to appreciate why people make new languages is because they look at a mess like this in an older language and think there must be a cleaner way to do it. But this is how HLA does it. So be careful about not crossing the procedures over on each other. Procedure greet, begin greet, whatever it does, end greet. All one unit without crossing over. Procedure greet by name, begin greet by name, end greet by name. So there's a chat question. Do I recommend learning Python? Yes, at some point you're going to be somewhere where they're going to use Python. They're going to use it either for like just a little tool to help themselves, or it may be their main language, but or you're going to be around scientists or mathematicians and they like Python. So for now, I would say at this moment, Python is still something that's very popular. So it's a good thing to know if you know it. It's not a particularly difficult language. It's very, very similar to Go and Ruby and C++ and C. All those languages are very similar. Rust. So yes, I would say, as answer to your question, do I recommend learning Python? That it's a good thing to know. Java. Java depends on the industry that you go in. So in the United States, and this sounds weird to say, but in the United States, Java is no longer very popular. It's used in a few places. I think Netflix uses it a little bit. But in the United States, it's not a very popular language for creating software, so I wouldn't recommend it for people who are going to work, say, in California as programmers. It's easy to learn if you found yourself having to, but if you would like to go overseas and work somewhere, then the chance goes way up that they're going to be using Java. And in that case, you might want to expose yourself to it. I can also tell you, by the way, is just when we're talking about programming languages, then the more programming languages that you have been exposed to, the better. It actually makes you a better programmer, in my opinion, to have a sense of how programming languages work and how they're used to express the solutions to problems. So I know Java from years ago. You're welcome. I can say Java is still popular for writing Android apps, but it's becoming less popular because they now support a language called Kotlin that appears to be more popular. Okay. So anyway, back to the procedures. I'm going to save that. It's got a star up there. And then I'm going to recompile it. The way I'm getting these commands back quickly, by the way, in the console is I'm using the up arrow. Up, 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 down, 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 up, 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 down, 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 down. So you can save yourself a little bit of typing just by using the up arrow on your keyboard, which will recall a list of commands going back a lot, like hundreds probably. All right, I left something out on line 12. I bet I know what this is. There's nothing particularly wrong that I can see on line 12. But my instincts tell me from using lots of programming languages that this parameter name may actually be a reserved word in the language, meaning you can't use it for a variable. So it's complaining about something near this colon. And since I'm in doubt here, I'm just going to change that to be like mname, my name, mname. There was another clue. I don't know if you noticed it. But if you look at the color of it, the color of it's the same as procedure, begin and end, and program. So that's another clue. Oh, the language actually recognizes this as one of the language words. Yeah, good call, Captain Price. So what I do in this case, when I realize that I've stepped on the toes of a reserved word, is I just change the name. Sometimes I'll use an underscore. Sometimes I'll put M, like my name, the programmer's name. Something just so that the language doesn't think I'm stepping on its toes. That's right. So let me go back to the console. So Killer Pear made a comment. If you type history, it'll actually show you kind commands going way back in time. By the way, if you see like here, command 136 in my history was the command I want to run right now. You can actually type an exclamation point in the number. In the Linux environment, call that a bang. But exclamation point 136 will actually rerun the command, that command number from your history list. So it's run it, and now I can do /lab4, or I could do bang 135 and get my output. Yeah, that exclamation point number thing is especially powerful if you did like a complicated command an hour ago and you can't remember exactly what you did, then you can go recover it pretty quickly. Oh, I forgot to call my function. So I'm going to go back into the code, pass in the string. So you guys are noticing this, but that name error, I should have picked up on that because it was highlighted in the same way as the language words are highlighted. So that should have been a clue to me that something was wrong, and I just didn't pick up on it. So I put an M on the front, and now it's not highlighted like that. So that seemed to please the... But I forgot to call the function. So here I'm going to call greet by name, pass in my own name. Go back to the terminal, use the arrows to recover my commands, and there's the two. You can probably, actually I'm not sure if that's true. My guess would be if you want to do HLA on your Raspberry Pi, you're probably going to have to get HLA source code and compile it for your Pi. That's totally doable, which would be a fun project to do, really, is to get this language on that platform. So you can get HLA in source code form, and you can compile it for Raspberry Pi. I'm addressing this question, by the way, because the Raspberry Pi is on a different processor architecture from your PC and my PC. I see. So the Raspberry Pi, by the way, that's the ARM processor architecture, which means it's designed with a slightly different set of instructions that it executes from the x86. You can do the same jobs with them, but the assembly programming is different. So what you want to learn, Captain Price, is bash shell programming. I'll call it scripting. If you look into that, you'll find it's something similar to what you do in BAT files. Okay, so I'm going to do one more procedure in my little example here. And then we're going to move on to the actual lab so I can get you started on that. So we have a procedure that takes no parameters. We have a procedure that takes one parameter. You can have procedures that take multiple parameters. But what I want to focus on here is a procedure that returns a value without returning a value. So I'm just going to call it give me 99. No parameters. Yes, you can do Android debugging on Linux. Okay, so give me 99. So notice I'm above the main block. I am separate from where greet by name ended, right? And greet ended. So here's the block for give me 99. And what I want to show you here is just what it looks like to return a value. Now, technically, HLA doesn't do return values. So the way you get a value from a procedure to some other place in your program is by putting it in a register. So I'm going to do an output here. And then what I'm going to do is I'm going to move 99 into the AL register. So this is what doing a return in HLA looks like. It's not a return statement. It's just the last thing that the procedure would typically do would be to move the result value into a register. So there's a question about what's the purpose of a variable if we can use registers and are sort of using registers so much. The answer is the registers are what is called volatile. And what we mean by that is that the registers are constantly being used and reused while your program runs, often when you can't see them being used or reused. So it's not safe to store data for long-term purposes inside a register because they're volatile. So we use variables for long-term storage. You might. So if you're using registers, you may find yourself having to restore values back into them constantly. There are other techniques, but the reason why we have variables is because they allow us to have a stable long-term storage of data. Okay, so that's what a return looks like. You simply use a move instruction to place whatever value that you want to return from the procedure into a register. In HLA, almost always it's some part of EAX. So since 99 is small, it's less than 255, it fits easily inside of AL, which can accommodate up to 255. So the way you call a procedure that returns something is like this. I'm going to run out of space. Let me stretch this out a little bit. All right, so getting a little bit at the bottom to say that. Anyway, so when you have a procedure that you know is going to return something and you call it, then what you do is you call it and then you immediately use the register that you know the procedure put the data in. So I'm going to call give me 99 knowing that AL is going to have the result value in it. Is that off the screen? Oh, it is. Let me get it back on the screen. Okay. Thanks for pointing that out, Captain Press. Okay, hopefully that gets the whole program. That's like a maxed out now. But I think you are now seeing what for me is the bottom of the window. There's the bottom of the window. Okay, got the whole thing on the screen. Thank you for pointing that out. Okay, so here's the greet function that I called earlier. There's greet by name that I called, placing my name in it. And then here's the one that returns a value. So I call it, and then the very next instruction, I take the AL that I knew the procedure returned data to me in and print it out. So I'll save that, and then I'll go over to the terminal and recompile it. So there's, I got 99 from the procedure. Hopefully you recognize this, by the way. If I don't typecast that AL, actually I'll ask it as a question. If I don't typecast that AL as an UNS8, what do I get? You don't have to tell me the precise data, but kind of what would be the system of values that I get. Good one, hexadecimal. So without this typecast on here, if I just put AL, it's going to be the decimal value 99, but presented in hex, which would not look correct. Right? So 63 is hexadecimal for decimal 99. So be careful about that. We typecast so we can get decimal, and that makes the numbers look normal to us. Good one, Glazer. That's true. That's correct. Okay, so hopefully everyone's, man, this virtual machine runs so much better on my Windows. It's sort of not great Windows gaming machine, but okay Windows gaming machine. Okay, so that's an example just of 3 different procedures. The one that's hard, I know, is the returning values, because return values are hard for people learning to program to begin with, and then you add into it HLA, which does and doesn't really return values. Windows is better for some things, just none of the things that I like to do, which is programming. In my opinion. Unless you're making games, and then I use the Godot engine on Windows, because you got to make your games for people on Windows. Okay, so that's my examples. I'm actually going to save those off to the side. Oh, this little hamburger up here, you can do a save as. So I'm actually going to save that off to the side. I'm just going to call it notes, and then I'm going to, let's start looking at your lab. So, okay, so that's my little example of procedures. This is not really assembly language. This is a high-level feature, but it's good practice for you if you're sort of still early in your programming career to see different languages and how they set up functions, to be reminded of what it means to create a function, to call a function, to pass arguments, to deal with return values. All that stuff is really good practice anyway. Also, making procedures means that we can write bigger and more interesting programs as we go and organize them well. I don't think that these will fold. Yeah, these are not going to collapse. If anyone figures out how to collapse it, by the way, that'd be cool. Doesn't look like it. No. Okay, so I'm about to load up the lab 4. Actually, I'll change my view just so you can watch what it is that I'm doing with that. So I'm just going to follow these instructions. I'm going to click on this link here. Yeah, it's a pretty crude editor, but it was very simple for me to create the syntax highlighting for our language in it. Yeah, most editors will do it. It's just the our little specialty language, I actually had to create the syntax highlighting for myself, for us. Okay, so here I am in the lab. So I don't remember if we've done it this style before. I don't think that we have, but we're moving into a different style of lab here where I've placed numbered comments in the code. So hopefully I don't ever make a mistake here, but this lab should have 10 numbered comments, which means that we have 10 tasks to complete in the code. I don't think that if anyone finds the HLA assembly language for any editor, please let me know, because that would be awesome. I saw on GitHub one person who started to do syntax highlighting for, I don't remember, Notepad++ or something, but it didn't finish. Okay, lab 4. It's got 10 numbered comments in it, which means there's 10 tasks to perform to complete the lab. And I get some reminders about that. So I'm supposed to grab the code, locate the number of comments, and complete the implementation based on the 10 tasks that I'm asked to complete. And I get one more reminder down here that there are 10 numbered comments, 10 tasks to perform to complete the lab. Okay, so I'm going to go get the code, and I'm going to go paste it into my programming environment. So this one's longer, and the reason why it's longer is because I've sort of pre-built a lot of the program for you. I thought it would be a little bit better in our online course format than just giving you a blank screen. So Instead, what I'm doing is giving you programs to go and complete a set of tasks to make the program work correctly. So what I like to do when I go to GitHub, you'll see the code, and you can highlight it and copy and paste it from here. I like to go to raw because I find it overall faster. So here's the raw code. Control A to select all. Control C to copy. And then I'm going to go back into my programming environment. I need to make a new file here. Actually, no, I'll just open the original lab4.hla. So I'm going to wipe this thing out. I still have the GitHub code in my, whatever you call that thing. I still have it copied and in a buffer. And now I'm going to Control A in here and hit the delete key to wipe out all of the lab4 that I was playing around with, and now Control V for paste, the paste, Control V to paste in the code for lab4 that was provided us to start. And I'm stretching the window out so that everything just kind of fits real nice. Okay, so I did a save as on the original notes that I made, and then I have a new lab4 file with all of the code from GitHub in it. It's commented up pretty heavily, so don't let that intimidate you. We'll just read our way down, and I'll show you some examples to complete it. I don't even know if it will compile to start, but I'm going to try it just out of curiosity. So I'm going to save it, lab4. I'm going to type clear to clear this screen in the terminal. So it does compile. I wonder if it does anything. It does do some stuff, although at some point it's probably going to break. Yeah, it's stuck right now. This is what I was hoping for, so that I could then tell you if you get a program that's stuck like this, what do you do? So my teacup stuck. So if you're running a program and you get stuck like this and you want to get out, what do you do? Let's try that. Yeah, so there might be. But since I know that I haven't really worked on the code, the quick way to just bomb a program, because, okay, I'm done with this for now, Control C. So Control C is copy everywhere else, but inside of the terminal here, Control C is how you kill. So you'll notice I did a Control C. It actually prints Control C more or less, and then I bombed the program out. So anyway, if you ever get stuck, or you just know that you need to bomb out of a program because you need to go back to the code, you can Control C and just kill it. It's fine. Okay, so some things to pay attention for. The requirements ask you, as they always will, to put the assignment name up here, put your name up here, and put the date up here. I just think it's a good habit that you need to develop to put some amount of documentation in your code, what it is that the code is, who it is that worked on it, when it is they worked on it. So that's 5 points for every lab for doing that. Now, as a teacher, the other thing this is doing is that you're certifying that it's your work when you do that. So that's why that's there. It's quick, but just make sure you hit it because it's 5 easy points to keep or lose. To fill in the blanks on every assignment. Okay, so let's just study it. Program lab4, so that's fine. Somewhere way down here is the begin lab4, and then in between is a bunch of other stuff. Procedures, I can see. I can also see some variables here at the top. So there's 3 variables. They are all unsigned 8-bit integers, which, because of your good work, by the way, really good work in the Piazza discussion, thank you for that. because of your good work in the discussions, you've all been exposed to the fact, or you know the fact, that unsigned 8-bit integers can store values between 0 and 255. So when you use an uns8, you've designed your program with the idea that that variable would never be less than 0 and never be greater than 255. So I designed this program thinking it's unlikely that anyone's ever going to play 255 number guessing games at once. Okay, now we hit the first procedure. So what I will normally do is put a comment on top of the procedure that tells you what it does. In this case, it prints a greeting. And then here's the first numbered task. So this program should have 10 numbered tasks, which means that you have 10 things to do to complete it. This one's fairly easy, so I'm not going to do it. Welcome the user to the game by printing a greeting. Welcome to the number guessing game, something like that, right? That's the first thing to complete the greeting. But you've already seen me implement something like that today. So, all right, here's another one. So that's the end of the greet function. Here's another procedure. Here's another procedure that will read in a number between min and max and return a value in the AL register. Now I did put a note here that this function is complete, just so you know it's not an oversight that there's no numbered task in here. I wrote this to show you how to do this. So we actually will improve upon this in time, but at the moment, this is a way that you can use a procedure to get a number from a user between a given minimum and maximum. And I'll show you the call to it later. But anyway, that procedure has already been completed for us. If you provide it with a prompt string, please enter a number, a minimum value, like I want nothing less than 1, and a maximum value, I want nothing more than 10. Then this procedure will do that and deposit a value in AL that you can then go get. That's that procedure. And there's the end of it, right? Okay, here's another one. So print messages letting the player know if their guess is too high, too low, or correct. Which I need to go fix the GitHub repo for that. Anyway, so that's what this function is supposed to do. This is, you might call this a Goldilocks problem. So you have a number that the user's guessed. You have a number that the computer is thinking. And then you compare the two. So here's a numbered task. Number 2, I'll get us started on that one. And then we'll refer back to this as a means of reviewing a concept that we talked about last week. So write the statements needed to let the user know how they are doing. Is your number too high? So I will need to compare BL. Does anyone remember, by the way, BL is how big? Out of T. 8 bits, that's right. So BL is an 8-bit register. It's the lowest 8 bits of EBX. The reason why I'm using BL for this is because user number is also 8 bits, right? So if this is 8 bits, then this has to be 8 bits. So I'm about to break a rule. In HLA, and then we'll fix it. So, but the nature of this task is simply if BL, which is their number, in fact, I already did it. I already didn't do what I meant to do. If user number is less than computer number, then don't forget, this part is just a pain, and you'll get compiler errors until you get used to it. Then a message. And then the trick about mushing the else and if together. And then after that, there would be only one other possibility. Okay, so I kind of ruined all the fun for you there, but it's because I wanted to use this one to review a concept. So this is not allowed in HLA, and you will get an error for it. In fact, let's go see the error. Hopefully I didn't do anything else that would cause an error, but line 47 is going to cause an error, or at least it should. So there it is, line 47. Memory-to-memory comparisons are illegal. So on line 47, it's saying you can't do a comparison between two variables. That's another, it's using the terms memory-to-memory, but what it means is a variable that you declared that is somewhere in RAM, in memory. So how do we get around this problem? In other words, how have I set you up to get around it? That's correct. So you have to offload one of these into a register for the purposes of doing the comparison. So the purpose of this line 42 here, which Captain Price has already answered, the reason why I'm doing this move user number to BL, remember move really just means, it means copy. So I'm copying the value of user number to BL, and the reason I did that is because I need to compare the value of user number, but I have to put it in a register in order to be able to do that. So this is an example, by the way, of us sort of starting to get some exposure to x86 assembly. This idea that we need a register, we can't just compare two things in memory in x86. So that's why this is here, move user number to BL. Is so that I could do the comparison. You'll notice, by the way, I didn't use AL. And in this program, the reason why I did not use AL is because I'm worried about at some point the user is going to do some inputs using AL, and I don't want to ruin that. So I'm being careful to use a different register here. Now we will look at techniques to manage that more in a better way. But for now, the reason why I used BL is because I wanted to be careful and not mess up AL. Okay, so that's that bit. This part's not going to compile right now, of course, but I wanted to leave that there as a breadcrumb for you. Okay, we're doing okay on time. So that's task number 2. Task number 3, so I'll do this one because this is one of those, we're actually doing a return, but a return isn't a return. So we're going to ask you this. So this procedure will just sort of capture the behavior that we want to ask the user, do you want to play again, and then figure out if they should get to play again. Okay, returns true in AL if they answer yes. So we have to sort of piece this one together. So this function prints out a prompt that asks the user if they want to play again, type yes or no. We get the single character. Now you've done this code, but you didn't do it in a procedure, I think, yes. Yeah, but we're actually going to use the word true. So Captain Price asked, would we move 1 into AL? You can do it that way, but I'm actually going to use the word true because HLA will let you do that. But 1 is acceptable as well. This flush input is here, by the way, because if you don't do that after inputs, you end up getting weird errors in HLA. So whenever you get something from the keyboard, it's a good idea to flush the input stream is what we'd call it, so that you don't get errors later when you try to do other inputs. Anyway, get C actually returns the character in AL. So we're going to use that fact to our advantage because right now their Y or their N that they typed is in AL. So if AL is yes. Let's see. What true is, yeah, true if they answer yes, or AL is a big Y, then move. So this might be a little off-putting. You can use the keyword true, and I'm going to do that here. This is going to feel funny at first, because hold on a second, I just had a character in AL, and now I'm moving a true value into AL, and the answer is yes, I am. True is 1. If you print AL, it should show as 1. So like you assumed, Captain Price, it will be 1, and false will be 0. So these are just sort of little sugar that the language has to make it easier to read the code. Okay, so this takes some getting used to, but registers don't actually care what kind of information they're storing. This AL will store 8 bits of anything. It'll store 8 bits of signed integer. It will store 8 bits of unsigned integer. It will store 8 bits of character, which is how much these characters consume in memory. And it will store 8 bits of Boolean values. So I know that doesn't look like 8 bits, but it's basically 7 zeros and a 1, just captured in the word true. So AL does not care what kind of data is in there, as long as it's the right size of data. So I'm actually going to overwrite the character data from the keyboard input with the Boolean data that I want as a result. And as long as they both are the right size, then I'm allowed to do that. But as Captain Price pointed out, you could use a 1 here and a 0 here. I happen to like I like reading the words. So that's number 3 complete. But remember, this is that weird returning a value without returning a value. We actually just move the result value into a register at the end of the procedure. Okay, so that brings us down into the main block of the function. So I'm just going to do a walkthrough here, and if there's anything that looks hard, I might do it. If not, then I won't. But anyway, one of your readings is about randomizing. You don't actually have to do anything. I just wanted you to be familiar with the fact that HLA can do random numbers, and then that may help you to recognize what I'm doing here. So randomize fires up the random number generator, and then I'm using it here to generate an unsigned integer in a range between 1 and 100. That's how the computer sort of picks their number for the game. Oh, this add instruction here is because I'm keeping count. So every time they go through the process of playing the game again, I keep count of how many times did they play. Like, okay, you're playing once. And then if they say I want to play again, then I'll add 1 to that counter. So games played is a counter that's being used to keep track of how many times did they actually play the game. Yeah, so that's games played plus plus. That's right. There is another way to do this in assembly, but I thought I'd put that off till later. So this adds 1 to games played. But Captain Price is right. That's the same thing as you would write games played plus plus in C++. Come on, scroller. So this whole for loop actually has inside of it. So they're playing again. The computer picks a new number, and now we just have another loop inside of here that they keep playing until they guessed. So the design of this program is that once you start playing, you have to keep playing until you guess correctly. You only get 10 guesses. If you want to implement that, you can, but this is just how many guesses does it take? So this is a loop inside of a loop, which is another thing that if you're sort of early in your programming career, you might not be super comfortable with. But this forever loop is, I want to play the number guesser as many times as I want. This repeat until loop is the number guesser. That's the game. Is there a way to escape without Control C, like return to the menu? There's breaks and stuff. So yeah, HLA has breaks, and they have a couple of different break setups. I'm actually going to show you one here in a second because I think you'll like it. Okay, so let's see, which ones of these look. So here's the number 4 task. So the purpose for this instruction right here, so I'm zeroing out num guesses. So now num guesses is during this round of guessing the number, how many guesses did it take them? But the forever loop is going to let them play multiple rounds of guessing. So if they start a new round of guessing, then they start with a new count of how many guesses that round, right? So games played is how many rounds. Num guesses is how many guesses in that round did it take you to guess. So I'm going to leave that one for you. So as soon as we get into the game loop, you are going to increment num guesses because they're about to make a guess for this round. Here's me calling the get number procedure. So it takes 3 parameters. The prompt, which is just a string that is whatever you want the user to see. In this case, I'm telling the user to enter a number between 1 and 100. And then the minimum value that I want it to accept is 1. The maximum value I want it to accept is 100. Now I know when I call this procedure that when it comes back, AL is going to have their number in it. I'm going to do number 6 here for us. So it tells me to call the show help procedure, passing AL to it. Oh, and the computer number. So AL presently contains the user's number that they typed in, and computer number is that randomly generated number. So that will pass those 2 arguments to show help. At the moment, Captain Price, if you put in a negative number, it will barf. We're going to fix that sooner than later, but at the moment, if you type hello or negative numbers or giant numbers, it will barf for now. But it is something that we're going to address sooner than later. Okay, so I did the number 6 task. The number 7 task, that one's fairly straightforward. You're just doing an output statement to say, oh, it took you 10 guesses that round. Okay, here's invoking play again. Play again takes no parameters, so I'll do that one. Invoking play again, is just invoking like you're familiar with. 101 will work. So Captain Price, if you type 101, then the procedure is going to recognize that that's a problem, and it will ask you for a new input. If you type 0, it will also recognize that. If you type -1, that's not unsigned, and it will barf over that. But 101, the procedure will actually tell you that's too big. Those are good questions, and everyone should experiment, by the way. This is a chance to sort of experiment with the behaviors of the program to see what it can and can't do. Okay, so I've invoked show help. And I know not everyone is comfortable with the fact that the argument labels don't necessarily match, but that's the user's input is there. And there's the computer number that I randomly generated. So that's a round. Print out how many guesses. I did not do that one. Number 8, invoke play again. Yes, that's a good point. So assuming that the user is going to make mistakes is just a good thing to have in your head. We spend a lot of time, if we have user-facing software, trying to figure out how to help them not make mistakes and deal with them making mistakes. And of course, there's also hackers out there that are seeing if making a mistake actually allows them to do some kind of exploit in your software. So it's definitely good practice to be thinking about what kind of mistakes can the user make, and how can I prevent that? Okay, so I'm going to do number 9. So play again returns a value. If I go read it, here's play again. Returns true in AL if they say yes, they want to play again. Otherwise, it returns false. So if I call this procedure and AL is false, they don't want to play anymore. And the quickest way to get out of the big program, the game, not the round, but the whole program loop, is a break if statement. So if I get back from play again, AL, and it's false, then they don't want to play again. They do not want to do another round. So this break if will pop you out of whatever loop is its parent. So the loop that's the parent of break if is not repeat until, because it's not inside of there. It's the forever loop is the parent of break if. So I call play again, and if AL comes back false after play again, that means I don't want to do the forever loop anymore. So that's number 9, which is, I think, a really nice way. I wish all languages had it. Some of them do, not all of them. A really nice sort of logic-based way of breaking out of a loop. And then number 10, so this is after they're not playing any more rounds. So you say, oh, you played 9 rounds this time. Hope to see you soon. Something like that is number 10. My program in its current state will not compile. Hopefully, I've armed you, though, with everything you might need to complete the lab this week. Some of these elements I did. I'll label them and then scroll through them just for the purposes of having them on tape on the video. So number 1, it did not do. Number 2, I did not do. I mean, I started it, but I didn't finish it. Number 3, I completed. So this code completes number 3. And again, this is for people that if you want to sort of hit pause on the video later, if you have a chance to watch it, then you'll see I did number 3. So if it's labeled completed here on the video, that means that I actually completed it. Number 4, I completed. Number 5, I didn't touch. Number 6, I completed on tape, on video here. Number 7, I did not do. Number 8, I completed. Number 9, I completed. And number 10, I did not do. So again, hopefully that'll give you a chance to sort of stop and pause and watch what is and isn't complete. If in doubt, start with a fresh copy and just complete them all for yourself, which is obviously slightly more challenging, but you can do it. Most things, I think pretty much everything, there is an example of how to do it somewhere in today's lecture. I'll point out, for example, that there's a break if in this get number procedure that breaks this forever loop that's its parent. And we did talk about returning values, we talked about passing arguments, and then we did some examples. So hopefully I've given you everything that you need to do to be successful in the lab. So I'm going to stop talking and I'll wait a couple minutes and see if anyone's got any questions for me. Otherwise, I'll just say have a good week, I hope. A productive week. I hope things have stabilized for everybody. If you're still getting settled in, then hopefully that getting that feeling of being settled in again comes sooner than later. Thank you, Captain Price. I appreciate it. That's it. Thank you. Tyler, thanks.